Okay, what we're going to do, we're going to talk a little bit about inequalities in a triangle. So things that are not equal. We've been talking about things that are equal to each other, right? Equal segments with midpoint, equal lines with equal angles with angle bisectors and all that kind of thing. But now we're going to talk about things that are unequal. Okay, they're not equal to each other. Let's start off real basic here. And let's do this. Here's a little, they just call it a key concept, the definition of inequality. So let's do this. I think this will be a good start. So watch. If 5 equals 2 plus 3, would you agree that that is true? Yeah. Okay, so if that's true, what I want to do is I want to compare 5 to 3, and 5 to 2, and I want to compare 5 to 3. So if this is true right here, if I added up 2 and 3 and I got 5, what could I say about 5 compared to either one of these? I could say that 5 is what? Greater than what? 2. It's got to be bigger than 2, right? And
it's greater than 3.
And 5 has to be what? Greater than 3. It's got to be greater than either one of these because both of those added together equal 5. Would you agree? All right, so this answer, this sum, has to be greater than either one of the things that are being added up. Make sense? Same thing with a triangle. So that kind of just got us started algebraically, and you've seen this type of triangle before. Remember this? The exterior angle, and these angles right here are the what? Remote interior angles. Do you remember that? So I'll label them as 1, 2, and 3. So what do we know about angle 1? We know that angle 1 is equal to what? Angle 2, talk to me, plus angle 3. That was that exterior angle theorem. Do you remember that one? Okay, and that made things a little bit easier for us. If I just knew these two outside angles, or not outside, but these two remote angles, right, the ones that are further away from this angle right here, all I got to do is add those up and I get angle 1. So, according to what we just did a second ago, what then, let's make a comparison between angle 1 and angle 2 and also angle 1 and angle 3, right? How do you think I could say that? I could say that angle 1 has to be what? Greater than what? It's not a very good greater than symbol. Greater than, still not very good. Boom, boom. That's better. Angle 1 is greater than what? Angle 2. And you can also say that angle 1 is greater than what? Angle 3. Make sense? Make sure you're pretty, you differentiate that greater than symbol because that can look a little like if you're a little sloppy on the angle symbol, which I tend to be sometimes, just make sure it's really different looking, okay? And y'all remember the greater than equal, don't you? Okay. All right, so that's greater than. Does that make any sense? So angle 1 is greater than angle 2, and angle 1 is greater than angle 3. And that's the kind of stuff they're going to ask you. They're going to give you pictures, and they're going to say, tell us which angle is bigger, or something. Compare angle 1 to angle 2. And without even knowing these numbers, without even knowing the numbers at all, I know for a fact that angle 1 has to be greater than angle 2, and angle 1 has to be greater than angle 3, because 2 and 3 add up to be angle 1. Make sense? So this sum has to be bigger than either one of the parts that's being added together. Everybody got that? Okay. So that's actually a theorem right there. That's theorem 5.8, but I don't care what the number is. They call it the exterior angle inequality theorem. Let's write that down. The exterior angle inequality. So it's not just the exterior angle theorem, because that's what we had learned before. The exterior angle theorem was this one right here, that angle 1 was equal to angle 2 plus angle 3. But the exterior angle inequality, right, quality theorem, yeah, this is the one, it's inequality. So inequalities always have greater than or less than, okay, not equal to. So this one right here is the exterior angle inequality theorem, which means that the exterior angle is larger than either one of the remote interior angles. Do you see that? What's that? Say it. No. Sure? Okay. So angle 1's got to be greater than angle 2, and angle 1's got to be greater than angle 3. Or you could go the other way. You could say angle 2 is what? Has to be less than angle 1, and angle 3 has to be what? Less than angle 1. You got it? Now what about 2 and 3? Does one have to be bigger than the other? No. One could be bigger than the other, right? Or they could be the same too, couldn't they? All right, and that's perfectly fine. Okay, let's look at this. Let's take this a little step further. And It's kind of interesting. Let's do like this. All right. Make sure you get the homework. Did you see the homework? All right, let's take a look at this right here. Which one do you think, A, B, or C, is the longest angle, or the biggest angle? Angle. Angle B, right? Why is that? On this particular triangle, yeah, it's obtuse, okay? And if you have an obtuse angle, that has to be the biggest angle out of the whole triangle. Do you agree? Because you can't have a... Are we listening? Okay. You can't have more than one obtuse angle, right? So you can only have one obtuse angle. That's bigger than 90. And so, yeah, there's no way anything else can be bigger than an obtuse angle in that one triangle. Okay, so that's your largest angle right here. Now, they don't do this in the book, but I'm going to do this here. I'm just going to make like a big old arc right here. Okay? So that's one big arc. And then you got these little two smaller arcs. You could do that. Now, watch this. Everybody watching? Up here. So this is the largest angle. And let's say that this was the smallest angle. I'll make that little tiny, okay, like that. And then let's say this is the medium angle. Is that all right? I'll tell you what. We'll put 2 for the medium. We'll put 1 for the smallest, 2 for the medium one, and we'll put 3, if I can reach around here. Should have made that so big. Okay, 3 for the biggest. Is that okay? So the book really doesn't do that, but as far as we're concerned, let's just say the one with 1 arc is the smallest one, the one with 2 is the next one up as far as how big it is, and then the one with 3 is the largest one. You okay with that? All right, so if I told you that, now you didn't know that just by looking at this, did you? You didn't know that angle A was actually smaller than angle C unless you would measure it or something like that. But with this stuff known, so let's write it. If I had given that, let's go... let's do the biggest first. So what's the biggest one? Angle B, right? Angle B would be less than what? Angle B, I'm sorry. What did I do less than for? Who knows? Angle B is greater than what? Angle, let's kind of go in order. What's the next one in line? C, angle C. And angle C is greater than what? Angle A. We could also say this. It's called the transitive property. Do you remember this? If A is equal, remember if...
But how do we know C is bigger than?
Because I told you. It's given. It's given. So I didn't figure that out on my own. I was given this stuff right here, okay? I don't even know if they'll write it out like this. I'm just thinking off the top of my head, okay? So let's do this. So angle B, right, is greater than angle C, which is greater than angle A. So what can we say about angle B and angle A? Angle B has to be greater than A. Would you agree? All right, and there's a thing on page 342 about the transitive property and all this kind of stuff. Remember, like if A is equal to B and B is equal to C, then what? Then A is equal to C. Do you remember that stuff? It's kind of like here. Okay, if B is greater than C and if C is greater than A, then B is greater than A. All right, it works with inequalities as well as equalities. Got it? Now, here's what I want you to see. This is kind of interesting. Is that if you have a triangle and you are given the biggest angle, you should know what the biggest side is. What, just off the top of your head, what looks like the biggest side here? AC. And look at AC in comparison to the biggest angle. It's what? Yeah, I'll put 3 things there. Yeah, it's across from it. It's opposite. Do you see that? So the biggest side is opposite the what? The biggest angle. You got it. It will be. It'll always be like that. Always, always, always. That the biggest side will always be opposite the biggest angle. What about the smallest one? This is the smallest angle, so which one do you think is the smallest side? Okay, BC. Right, opposite. You're exactly right. So the side that's opposite the smallest angle is going to be the smallest side. So what about AB? That's going to be like the middle one, the medium one, right, if you want to call it that. Okay? So you got the biggest one, the smallest one, and the one that's in between, the medium one, if you want to call it that. It's fine with me. Everybody okay with that? That's pretty simple, isn't it? It got me thinking about a right triangle. Because it doesn't always have to be an obtuse triangle. It could be any kind of triangle. But let's do a right triangle. And we have special words for a side on a right triangle. So if this is my right angle right here, what did we say the side opposite the right angle was? We gave it a special name. We called it the hypotenuse, didn't we? Hypotenuse. And what do we always learn about the hypotenuse? Well, it's opposite the right angle, but it's also the what? The longest side. Did you ever wonder why it's the longest side? Well, now we have a theorem to tell us why it's the longest side. Because on a right triangle, the right angle is always going to be the what? The biggest angle. So what's the side opposite the biggest angle? The biggest side, right? So the hypotenuse will always be the longest side. Does that make sense? And it works because of this particular theorem. And let me see this theorem. Do they give it a name? They don't really give it a great name. They just say it's an angle-side relationship in a triangle. But it is a theorem. I mean, you have to, it's kind of wordy. Look on top of 344. They don't give it like a special name. But it says, if one side of a triangle is longer than the other side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. That's kind of wordy, but basically it's saying that the side opposite the biggest angle is the biggest side. Agreed? What do you think the converse of that would be? Exactly, and that's another theorem, okay? Like the first theorem is 5.9, and then the second theorem, the converse of it, is 5.10, right? They don't give it any special name, they just number them, but that would be true too. So if I had a, let's draw another picture here. It's easy when you go obtuse because it's a little more obvious. We'll make it go like this. Is that all right? If I go obtuse? And that's why they use obtuse a lot for these kind. So here's an obtuse. So now what if I knew this? What if I knew, watch, A, B, C. What if I knew that AC was my biggest side? I didn't know anything about the angles, but I knew that AC was my longest side. Or I could do this. Watch, I could even number it if I wanted to. Now, this is not going to work. Let me think. Let's say that was 12, and this is 5, and this is like 9. I think that'll work. Yep. Okay, so what if we had something like this? What if I gave you those sides right here? Could you tell me from that information what the biggest angle is, what the smallest angle is, and what the medium angle is? Absolutely. What would the largest angle be? Let's go in order from largest to smallest. Okay? That's a weird est. Writing terrible. So from the largest angle to the smallest angle. Let's go in order. Which would the largest be? Angle B. What would the next one, the medium one, be? It would be angle C. Good. And what would the smallest one be? Angle A. You follow me on that? And that's kind of what they're going to do. Okay, they're going to. It's not that hard. They might make it a little trickier, you know, put variables in there and solve for them and all that kind of thing. But I'm not really sure. I have to take a look what they're going to do. Yeah, but the picture's not going to look quite this easy. Sometimes they'll make it a little bit trickier for you. But that's basically what you have to do. Everybody got that? So you look for the biggest side. Now they could do the same thing with the angles, couldn't they? I don't know. Let's draw one that maybe is not obtuse. Let's make it look kind of acute. I don't know. What do you think that angle is right there? About 70? We'll just make this up. And this is 50? Yeah, that'll work. Okay, we'll say it's 50. I don't know. And then, so if that's 70 and that's 50, what's this have to be? It's got to be 60, doesn't it? Because that's 120, right? And 60 is 180. Would you agree? So remember, they have to add up to 180 degrees. So let's do this. X, Y, Z this time instead of ABC. Getting tired of ABC. So they could give you something like this, and they say, what is the, let's go in order from the smallest to the largest. Make sure that you do read the instructions carefully. From the smallest side to the largest side. And you have to write down what it is. So what's the smallest side on this triangle right here? XY. It's XY, right. How do you know it's XY? Because it's opposite the smallest angle. Exactly right. Okay, so XY is the smallest line segment, XY. What's the medium one? YZ, very good, because it's opposite the 60, which is the medium angle. So it's YZ. Put the line segment over top of it. And what's the largest angle? It's XZ, or not angle, but side, I'm sorry, XZ. All right, so that's the smallest, that's the largest. Now you got to make sure that when you look at it, you understand which one is first, because sometimes we'll switch it up. Sometimes we'll say give me the largest to the smallest. Sometimes they'll say give me the smallest to the largest. So make sure you read it carefully. You put it in the right order. It definitely matters. It absolutely matters what order you put these in, okay? Because that's what they're asking about. They're asking about the order of those sides, those segments. We good with that? All right. Let me just take a peek, see if I'm missing anything. I think I pretty much covered it. Now, you know the problems aren't going to be this easy, okay? They're going to be a little bit more challenging, but it all basically comes down to these basic principles that we were talking about, okay? So those are inequalities in one triangle. Now, we are going to do inequalities in two triangles in a little bit. Not the next lesson, but I think the one after it. Maybe, maybe not. Triangle inequality 5, 6. Okay, so there's a few lessons before we get to inequalities in two triangles. All right, but this is inequality just in one. I'm just looking at one triangle and looking at the angles, figuring out which side's bigger, which side's smaller. Everybody good? All right, let me give you the problems to do tonight. Well, not much, but a little bit. So section 5.3. Well, we didn't answer quite. We just went over the...
We have like 3 minutes. But I thought it ended 39. 33.
It's Monday 33. Yeah, we got 3 minutes. All right, so let's see. Pages 346, 347, and 9 to 37. But they're probably easy, though. There's probably not a whole lot of figuring. It's just looking at them, figure out which angles are bigger, which angles are smaller. Then you look opposite, and you look at the sides and that kind of stuff, okay? Now, again, they're not all as easy as what we did in class today, but you might have to think a little bit.
I know, that's a lot.
Oh, you guys are fine. Yeah. I used to, at my other school, I gave 30 problems every night. Every night. I had a book that there was 30 problems, and I gave all 30 every night. So count yourself lucky.